So let's say we have a problem. The number function below is starting until the tension in cable AB is 2.4 kilonewtons. Question says determine the moment about point O of the cable force acting at point A and the magnitude of the moment. That's the question. Okay, so the first thing to do always is to outline the free body diagram. I've always said that whenever a problem is given to us in applied mechanics, the first thing we do is always to outline the free body diagram. So we draw the free body diagram for a three-dimensional force system. Okay, so we try to represent what we see from the thumb up on this side. Okay, so in three dimension we have this. Okay, this is completely straight. And then then we have the cable from point A, this is point A. We have the cable that goes like this. Okay, around this is point A, and this is point B. We have a cable around here. Okay. Distance from there to this cable is something like this. Distance from this point to the cable is 1.6 meters. And distance from this point to this point is 0.8 meters. 0.8 meters. Okay. And then we have this one. Okay. We have another. Right. Alright, so this is what the free body diagram looks like. Distance from point A to point F is F. That's the distance from this point to this point. The value is 2.6 meters. Oh, sorry, 1.6 meters. The value is 1.6 meters. Alright, so let's call this direction Y. Now this is three dimension. You can choose, unless otherwise stated, you can choose to call any direction any value you want. So let's call that Y. Call here X. And call here our Z direction. Remember that I said Y direction is always in J. You need the vectors. I direction, J, and X direction is always in I. You need vectors. While Z direction is always in K. K direction, you need vectors. Okay, so this is the point O, where we are taking our moment about point O. Okay, so this is the first thing we do. First thing is to plot the free body diagram. Alright, so after obtaining the free body diagram, the next thing to do is to find what is called obtain the position vector of the cable. So obtain position vector of cable. Okay. Of cable. So to obtain that, the cable is between and the cable runs between point A to point B. So in order to obtain a position vector between A and B, we call that R, A, B. So position vector between A and B. Alright, first thing first, sorry. Before we get R, A, B, position vector, choose an arbitrary point, the origin. This is the origin. Move from the origin and locate all the points. Move from the origin and locate all the points. In this case, we'll have just 2 points. We have B and point A. These are the 2 points we have on this table. So move from the origin to locate point B and point A. So at the origin, to locate RA, position of RA from the origin, we move from the origin. To locate A is upwards. Remember, this height was given. The height was given as 2.4 meters. So the height of the cable is actually, or the dumbbell is 2.4 meters. Okay? So move from the origin to locate point A. So you move from the origin. As you move to locate point A, you're moving upwards. Since you're moving upwards, you're going in the positive direction of Y, which is J. So since you're moving in the direction, distance covered to get to point A simply was 2.4 meters in the I direction. So it means the position of point A is actually 2.4, sorry, in the J direction, because A is at the end of the y-axis, which is J direction. So from the origin to locate point A is actually moving from 0 to 2.4 in the positive y direction, which is the J axis. Okay? That's locate point A. Then to locate point B, we also move from the origin to locate point B. To locate point B from the origin, we can move a distance from this point to somewhere around there, which is indicated here. To locate point B from the origin, you're moving this direction, this is positive I direction, as the positive x axis. So move from the origin to locate point B, you move this distance. This distance is signified as 1.6 to locate point B. So moving from here to here is same as moving from here to here, but it is not yet at point B. Point B, once you move from here to this point, you now move from this point to this point to locate point B. Moving from this point to this point is actually move from here to this point, which is 0.8 to locate point B. So to locate point B, actually move a distance of 1.6 in the I direction, and then move from 1.6 in the I direction down to 0.8 in the K direction to locate point B. So moving from the origin to locate point B, we moved 1.6 in the I direction, positive, because really positive x axis. So you have 1.6 I is positive, and from 1.6 I you move to locate point B, which is coming in this direction, which is positive. In this direction is positive K axis. So you move in this direction from this point to this point, which is 0.8 in the K direction, so plus 0.8 K. Okay, so this is the position of A on the diagram, this is the position of B on the diagram. The next thing to obtain now is the position vector. Position vector is the distance or the position between A and B, and that position is simply RB minus RA. That's the position vector between A and B. So RAB is now equal to RB gave us 1.6I, okay, plus 0.8K minus RA is 2.4 J. Okay, so you may wish to rewrite this equation to be in terms of I, J, and K. So you can simply say the position vector between cable AB is simply 1.6 I minus 0.8 J plus 2.4 K, 2.4 J, okay, plus 0.8 K. So this becomes the position vector of cable A and cable B. Having known this, the next thing to find after obtaining the position vector, you find the magnitude of the position vector. Alright, so after obtaining that, you find the magnitude of position vector. Magnitude of position vector. Okay, that's simply means RA, B, and that's equal to the square root of the sum of the squares of individual position. So you have square root of 1.6 squared which is 1.64 squared plus 0.8 squared, if you wish, squared plus 2.4 squared plus 0.8 squared. Now notice that I've omitted the minus 2.4 because the square of the negative sign will also always give us positive, so there's no need to put the minus. Alright, so the magnitude of position vector AB is now equal to the square root of 1.6 squared.
2.56. 2.56.
2.56 plus 2.4 squared.
5.76.
5.76 plus 0.8 squared, 0.64. 0.064.
0.064.
Is it 0.064?
Yes.
0.06.
No, 0.64.
0.64. So magnitude of position vector AB is now a square root of 2.56 plus 5.76 plus 0.64.
8.96.
8.96. So what is the value of the magnitude? Take the square root of 8.96.
2.9993.
So this is 3.0. So which means magnitude of that position vector is simply 3.0. Now after obtaining the magnitude, the next thing to find is what we call unit vector. The unit vector in table AB, and that is signified as lambda AB. Lambda AB means unit vector in AB. This is symbol for unit vector, and that's equal to the position vector of AB all over the magnitude of the position vector of AB. That's equal to the position vector equals 1.6i plus 2.4 minus 2.4j, okay, plus 0.8k all over 3.0 is 3. So you can break this equation down to simply say unit vectors in table AB is now equal to, this is simply 1.6i divided by 3 minus 2.4j divided by 3 plus 0.8a divided by 3. Okay, that will give us the unit vectors. Okay, therefore, unit vector in table AB is now equal to 1.6. 1.6 divided by 3.
0.5333.
0.53i minus 2.4 divided by 3.
0.8.
0.8j plus 0.8 divided by 3.
0.26.
0.26k. Okay, so obtaining the unit vectors, the next thing to find is the position vector of the tension in table AB. So find position vector of tension in table AB. That's the next thing to find, and that position vector of the tension in table AB is simply the magnitude of the tension in table AB times the unit vector of tension in table AB. That's the formula. The magnitude of tension in table AB times the unit vectors in table AB. Magnitude was given to us in the question as 2.4 kilonewtons. So where the magnitude was given, where TAB was given as 2.4 kilonewtons. So that simply implies that the position vector of this tension in AB is now equal to, magnitude is 2.4 and the unit vectors is what we obtain here is 0.53i, okay, minus 0.8k, okay, and plus 0.26k, okay. Alright, so it means that the friction vector of the tension in cable AB is now equal to 2.4 times 0.53. Let's expand the brackets to 2.4
and 0.272.
2.5.
1.2272.
1.2,
72.
okay,
27.
1.27 I, okay, minus 2.4 times 0.8.
1.92.
1.92 J plus 2.4 times 0.26.
0.624.
0.624 K. Okay. So this is now the position vector of the tension in cable A. The question says we should find the moment about point O, and moment of this force in this cable. Moment of the force in this cable is simply, this is the tension, this is tension in cable A. Position vector of the tension. Moment is simply force times distance. So it is the force of the tension or the tension force itself, position vector of the tension, which is gotten here, times distance it makes about point O. This is point O. And distance from this point A to point O is simply what? 1.6 meters. Distance from point A to point B, point O, but this is F, and this F is actually point O, this is origin. Moment is force, it takes this table, times distance, it takes theta force to get to what? The point of the origin. The distance from this origin to this point is the same distance as from here to this point, which is 1.6. So it means moment of this tension, so this position vector of the tension, times the distance it takes to get to point O. So distance is simply what? 1.6 times the tension force. So moment of A about O, or moment about O is simply, the position vector of the moment is simply tension, position vector of the tension in the AB times distance it takes to get to that point O, and that distance is 1.6 meters. That's the distance it takes that cable to get to point O, 1.6 meters. So therefore, moment, position vector of the moment about point O is now equal to 1.6 times the tension. Position vector of the tension is 1.27 I minus 1.92 J plus 0.62 K. Okay, so moment about point O is now equal to 1.6 times 1.27. 1.6 times 1.27.
2.032.
2.03 I minus 1.6 times 1.992. 1.6 times 1.92.
3.072.
3.07 J plus 1.6 times 0.62.
0.992.
0.99 K. So this becomes the moment about point O. But the question says find the magnitude of the moment. So magnitude of the moment is simply MO bar, and that is simply the square root of the sum of the squares of the individual moments. So that's 2.03 all squared plus 3.07 all squared plus 0.99 all squared. So notice again, I've omitted this negative sign. It doesn't matter. Even if you put the negative sign here and you square it, it will still turn to positive. That's why I keep on omitting it, but it doesn't matter. Okay. moment, magnitude of moment is now equal to square root 2.02 square.
4.1209. 1209.
4.12 plus the 3.07 square.
9.4249.
Plus 0.99 square.
0.9801.
0.98.
98.
Okay. So the moment magnitude is now equal to square root. Add all of them 4.12 plus 9.42 plus 0.92. Sorry, plus 0.98.
14.52.
14.52. So this simple magnitude of the moment about from O is now equal to the square root of
3.8105.
81 kilo meter. That's the answer.